In this problem, we are given an elevator weighing 9.80 kilonewtons moving downward from rest until it attains a velocity of 30 meters per second after it travels a distance of 6 meters. We are tasked to compute the acceleration of the elevator in meters per second squared, the time the elevator travels at this instant in seconds, and the tension of the supporting cable in kilonewtons. And to solve for the first problem, we will use the equation in kinematics to solve for the acceleration given the distance and velocity, that is Vf squared, final velocity squared, equal to the initial velocity squared plus twice the acceleration times distance. We have Vf equal to 30 meters per second equal to the initial velocity of 0 since it is going from rest plus twice the acceleration times the distance of 6 meters. We get our acceleration equal to 30 squared equals 2 times a times t. Shape solving, we get a equals 75 meters per second squared. For the second problem, we will use another equation in kinematics to solve for the time the elevator travels at this instant in seconds, that is, the distance d equal to the initial velocity times time plus 1/2 the acceleration times the time it takes to travel squared. We have d equal to 6 meters equal to the initial velocity of 0, so this overall expression is just equal to 0, plus 1/2 times the acceleration of 75 meters per second squared, which we solved a while ago, multiplied by time raised to the power of 2. We can solve for t, that is 6 equals 1/2 times 75 times t squared. We get t equals to 0.4 seconds. And for the last problem, let's say we have our elevator here connected by a supporting cable that is exerting a tensile force, let's call this T, and a weight of W that has a value of 9.80 kilonewtons or 9,800 newtons. And since it is going downward, it has an overall net force that is equal to its mass times the acceleration. Now to solve for T, with the summation of force vertical, considering upward forces to be positive, equal to the mass times the acceleration, since it is moving, and because it is going downward, therefore the sign here should be negative. So we have tension T going upward minus the 9,800 Newton force equal to negative times the mass. To solve for the mass, we know that weight is equal to the mass times the gravitational acceleration, and to get the mass, we divide weight by the gravitational acceleration. So we have a weight of 9,800 newtons divided by 9.81 meters per second squared, and we have an acceleration of 75 meters per second squared. Now we can solve for t using our calculator. We have t minus 9,800 equal to negative 9,800 divided by 9.81 times 75 equal to, we get x equal to negative 65,123. Now one important thing to remember is that a cable or a rope or a wire cannot carry compressive forces, which means that our T here cannot be negative, which means that the force carried by the wire or the cable is equal to 0, because ropes or cables cannot carry compressive force, which means that our final answer here is T equal to 0, which means that our elevator here is in free fall.